Hello everyone. So welcome back. Today we have x plus 9 all raised to the power of 2 equals to 49. X is the unknown. So we're going to solve together. Let's say solution. So we will solve this in 3 weeks, and the most exciting one is the last one. So I want you to stay tuned to the end. So if I say x plus 9 to the power of 2 is equals to 49. This is the first method. We're going to take the square root of both sides so that this square can be cancelled out. That is x plus 9 to the power of 2 square root is equal to square root of 49. And definitely this square root can cancel the square so that s plus 9 will be equal to plus or minus square root of 49. And here we would like for s to stand alone so that s can be equals to plus or minus square root of 49 minus 9. As the 9 crosses the equal sign, the sign definitely will change from positive to negative, and we are fine. So therefore, s is equals to plus or minus 7 minus 9. The square root of 49 is 7. And here we have two values for s, that is s1 is equals to plus 7 minus 9. And this will answer becomes minus 2. And for s2, it is minus 7 minus 9, and which is equal to minus 16. This is the two values of s for the first method. And again, for the second method, we have s plus 9 to the power of 2 equals to 49. Second method. Here we are going to consider the identity from algebra for the sum of two squares. That is, when a plus b raised to the power of 2, they are represented as a to the power of 2 plus b to the power of 2 plus 2ab. Here, a is equal to x and b obviously is 9, so that their equation becomes x squared plus 9 to the power of 2 plus 2 times x times 9. This is equal to 49. And if you simplify further, we have x to the power of 2 plus 9 to the power of 2 is 81 plus 2 times 9 times x, that is 18x. And this is equals to 49. So if we simplify further, we're going to see that this x to the power of 2 plus 18x plus 81 minus 49 all therefore equal to 0. And here x to the power of 2 plus 18x, 81 minus 49, and that is plus 32 plus 32 all equal to 0. So here is a typical quadratic equation, and factorizing this, we're going to consider the product. And the product here is 32, which can be achieved as plus 2 times plus 16. 2 times 16 is 32, and the sum is 18, equals to 18, and this can be achieved also as plus 2 plus 16, and it's plus 18, so that our equation can become x to the power of 2 plus 2x plus 16x plus 32 all equal to 0. Here we're going to factor out the common terms. So what is common to the first two terms is x, bring out s, and s squared divided by s, that will be x, plus 2s divided by s, that will be 2. Close the bracket. Here, what is common is plus 16. 16s divided by s, that will be s left, plus 32 divided by 16, that will be 2, all equal to 0. So we're going to write the common terms. S plus 2 is common to the two terms, so we write it once as S plus 2, close the bracket, open the bracket quickly, and write what is left here after taking S plus 2, which is X, plus here what is left is 16, close the bracket, all equal to 0. Here, this leaves us with the zero product rule, and it says either S plus 2 is equal to 0 or X plus 16 is equal to 0. And from this other side, we have S to be equal to minus 2. So the first value of S, and here S is equal to minus 16, and it's fine. So for the third method, S plus 9 to the power of 2 is equal to 49. And this is the third method and the most exciting. So here we're going to employ the concept of difference of two squares. So if we rearrange our equation as S plus 9 to the power of 2 minus 49 equals to 0, it will be fine. So here, X plus 9 to the power of 2 minus 7 to the power of 2 is equal to 0. So 7 to the power of 2 is 49. Here, this is a typical example for the difference of two squares, which is represented from algebra as a to the power of 2 minus b to the power of 2 is equivalent to a plus b times a minus b. And our 8 is x plus 9 and b is 7. So that our equation becomes x plus 9 plus 7, put in a bracket, and s plus 9 minus 7 is all equal to 0. 9 plus 7 is 16, so we have s plus 16 times, and 9 minus 7 is 2. So it's left with s plus 2. If we close the bracket, it's equated to 0. So here we have two cases, and it says s plus 16 is equal to 0, or s plus 2 is equal to 0. So here we can have s to be equals to minus 16. And also from this side, s is equals to minus 2. So from the first method, we have x to be minus 2 and minus 16. So second method also, we arrive at the same answer, minus 2 and minus 16. And the third one also gave us the same answer, s is given to be minus 16 and minus 2, and we are very fine. So what to verify is if actually the value for s satisfy the original equation. So here, our original equation is s plus 9 to the power of 2 equals to 49. So for s equals to minus 16, here we have minus 16 plus 9 to the power of 2. Can this be equal to 49? But minus 16 plus 9, that is minus 7 to the power of 2. We want to verify if this is equal to 49. Of course, minus 7 squared is 49 is equal to 49. So it's true for s equals to minus 16. So let's check also if for s equals to minus 2, we satisfy the equation. So here, s plus 9 to the power of 2 is equal to 49. So in the place of s, we are going to write minus 2. So here, this is equals to minus 2. So s minus 2 plus 9 to the power of 2, can this be equal to 49? Minus 2 plus 9, that is 7 to the power of 2, is definitely equals to 49, because 7 to the power of 2 is 49, is equals to 49, and we are fine. Thank you for staying tuned. Bye bye.